I'm here to discuss a program where I'm starting where I intend to move us beyond passwords to a new method of authentication. Everyone knows there's a problem with passwords. What I'd like to do is I'd like to move to a world where you sit down at a console, you identify yourself, and you just start working. And the authentication happens in the background, invisible to you, while you can continue doing your work without interruptions. Later, you're going to hear Howie Schroeb talk to us about how he's going to, in the crash program, he's working to make the machines aware of themselves and their environment. What I want to do in this program is I want to make the machine aware of its operator. This thing. So here we have, I've taken two slides from earlier before and I've combined it together to show you some of the unintended consequences of the problems we're having with passwords right now. I'll call your attention to the yellow sticky first. There we got listed 5 passwords and the person's developed a pattern to track their passwords. Personally, I think if you've only got 5 passwords, you have to worry about you're a really lucky person. But behind that, I've got the core logic chart showing us how many passwords they cracked over the 2-day period, with the x-axis showing you every 2 hours and the y-axis showing the number of passwords that are cracked. The message I'm trying to show you inside this slide is where we have too many passwords going on, it's forcing us to go into develop patterns because humans aren't built to remember random connections of strings. And as long as we're using words inside our passwords, we're always going to be crackable. That's the message of the core logic slide. So how do we deal with this? The way DoD looks at us is said, okay, well, let's make really strong passwords. Passwords like these. These 3 passwords here meet DoD security requirements. They have 15 characters, they got random characters, but the problem is they don't meet human requirements. Again, humans aren't built to understand random connections of characters. We have to have some sort of pattern to be able to remember this. And unfortunately, an Air Force study was able to determine that patterns in keyboard walking are just as easily detected as patterns inside words themselves. So what is the real problem here? The problem is we're focusing on something else than the user. We're focusing on a password to authenticate to our systems. What we really want is the person of this keyboard. We're focusing on a proxy for the system. So how do we move from proxies for you to actual you? We do this on a daily basis, and I'll walk you through an example that should highlight this fact. If I could give you the key to my house, you could walk to my house and it would be as if you were me. You'd walk inside, be able to unlock the door, and the house is yours. You walk into my living room and my dog would lift her head and she'd look at you and go, okay, that doesn't look, and you go, I've got the key, I am Richard. And the dog would go, no, you don't look like Richard, you don't smell like Richard, you're not walking like Richard, because the dog is cycling through different modalities just like we do every day when we deal with people. The dog is not focusing on one single thing, and that's what this program, Active Authentication, is trying to do. It's trying to find those aspects of you that are unique and capture those and allow that to be how we authenticate you to the systems, not a specific key that you have to get to. Now let me go into some of those modalities here. Here I've given you 3 examples of modalities here. On the left-hand side, we have an existing technology. In the center, we have an area where I believe there's technology existing that we can repurpose to identity authentication. And on the right, a new technology. Now let me start with the left. Everyone's familiar with how with the fingerprint, there's enough, the little swirls on your finger are enough to make you unique in the world. Apparently, by collecting data on the 12 different aspects of your fingerprint, we can capture who you are with enough fidelity to keep you unique. But also because it's physical, we can also develop a physical device to spoof you, such as jelly fingerprints. The center one is an example of mouse tracking, where apparently the swirls of the way you move your mouse connect back to the way your eye tracks on the screen, which is an existing biometric which can track you. This doesn't have the same fidelity as fingerprinting. It's about 75 to 85% accuracy based on the research you look at. But it's being looked at heavily by marketers like Google to track who you are and who's at the keyboard, because they want to be able to target information to you more directly than they can using demographics or psychographic marketing. Well, it's my feeling that by taking research like this, we can take another step and go the next step to capture who is actually at the keyboard and use that for identity authentication. Now, I should stop at this moment because there's some people in the crowd who may be a little concerned about the fact that we're talking about making the computer aware of who's actually at the keyboard. Now, that is a serious concern, but we're going to control that throughout the program. Because what I'm trying to do is I'm trying to make the computer aware of who's there to tie your identity to the access you have to the systems, to try and connect identity to level of risk of what you're connected to. We're not concerned about, we are very concerned about capturing the aspects of you, but we don't want to store this information. We need to capture this and keep it in a way so that if we stored it in some sort of database somewhere, the hackers could get to that and just, this program would have absolutely no value. So what we're trying to do is keep the information protected and make you the key to your system instead of having some external thing the key to the system. On the right-hand side, I have forensic authorship, which is a field where you can go through the statistical information on the information and something you've written and determine who the author is. I've given you here a page from the Manchurian Candidate because forensic authorship was used to demonstrate that several sections, even chapters, were taken from I, Claudius. The forensic authorship right now is used currently inside law enforcement and is used and accepted inside our criminal system as a valid method of proof for identity. If our court system can use this as a valid method of identification of identity, I don't see why we couldn't develop a computer program to do the same sort of thing, tracking what you're typing as you're typing to validate your identity. Now, I've given you 3 items here, 3 examples, the 2 on the right being new modalities. These are examples of what I'm looking for. These aren't actually what I'm looking for. I'm looking for things like this to identify who you are. But the concept I'm trying to find is more than one thing, not just one solution to connect you. Like the example I did with the dog, where it's using more things. When you interact with people, you're really using more than one method of authentication. We want to have more than one modality connect who you are to determine who's at the keyboard and actually make it much harder for the system to be spoofed. Now, if you're interested in getting more detailed information, we have an industry day coming up on November 18th. I've got the contact information on the screen and the emails there. So thank you very much.